just before we do make a start and I introduce Lizzie, a couple of things. Tonight, as you've seen in my email, we're asking questions a bit differently tonight. So once Lizzie has done her presentation, if you ask your questions through the chat function, and then Rose, my colleague, will moderate them and ask Lizzie on your behalf. If there's anything you're not understanding during Lizzie's presentation, just again, put it in the chat and Rose will interrupt Lizzie to say, just can you elaborate further? What we are not going to do tonight is, because we are pushed on time, it is extremely hot. We are going to stick to the questions regarding the subject. If you have any questions around the subject or different from the subject, please use the Teams channel to debate and chat, because we just want to stick to the subject in hand, because we are pushed for time. So as many of you guys know, Lizzie is our colleague on the climate change team. You'll recognise her from our forums and our previous webinars. Lizzie has significant experience in the energy sector in the UK and the Isle of Man. So she was our perfect person tonight to present to you. Like I say, you will be on mute. You might see me or Rose muting you. It's just to sort of stop any background interference and make sure we sort of stick to timings. Okay. Is there any questions before we start?
How do we access the chat function?
Oh, right, John. It should be in the top of your. If you can see your icons at the top of your screen, it says show conversation. If you click on that, it should show you you should be able to use the chat function to ask any questions.
It's in the top bar.
Oh,
it looks like
that's it. Okay. Yeah, got it.
Yeah.
Thank you.
No worries. Lizzie, I'll be quiet now and let you crack on with your presentation.
Thank you, Andrea, and thanks for dialing into the webinar tonight, everyone else. So I'm presenting tonight the Isle of Man future energy scenarios, which was, if you remember back to February, we had our consultants over at Arup present to you about energy on the Isle of Man. And they were at the time undergoing significant analysis and producing a report for us to come up with some of the best options for the Isle of Man in terms of our future energy and tying in with the government targets. So we presented this presentation to Tynwald on the 30th of June, and some of you may have heard elements of it discussed this week as well. Okay, so just to familiarise you all with the climate targets for electricity, in December 2020, the government launched its future energy scenario strategy, and the key aspects that we were looking at for this strategy was to ensure 75% of the island's electricity is generated from renewable sources by 2035, and the long-term target of delivering net zero emissions in electricity by 2050. After the latest ETHER report that's come into us, we know that electricity generation on island is responsible for about 33%, so a third of all of the greenhouse gas emissions on the Isle of Man, and it is the most significant sector. So with that in mind, for other sectors to decarbonise, such as heating and electric vehicles, it's really important to target this electricity sector first. If we're relying on fossil fuels to power our homes and our electric cars into the future, that source of energy needs to be clean for our emissions to really go down. We discussed the energy trilemma last time we presented to you. So the trilemma is a concept that's been developed by the World Energy Council. It's the three key aspects of electricity generation. So first, being, or the top of the triangle, is the environmental impact of supply. A lot of what we look at is to do with the greenhouse emissions, but there are other important elements, environmental concerns to consider as well. Key to many people is the cost and affordability of our electricity. So there are some sources that are the absolute best for the environment, but they end up being very expensive in the long term. And specifically for the Isle of Man, one of our most important concepts for electricity is the security of supply. So a lot of our business on islands rely on there being a very reliable source of electricity on island. And as many of you remember, we haven't had a major blackout on the island in the last 20 years because of what we currently have. So just to summarise the current generation mix, we have most of our electricity is being generated from the power station at Pulrose. That's a combined cycle gas turbine. We import natural gas from the UK and use that to generate electricity in gas turbines. Some of that process is captured and waste heat is recovered, and that also goes on to power a steam turbine. That's the major source of electricity on island. As a backup, and also something that allows us to export electricity, we have the interconnector connecting us between Douglas and Bispham. So we can import down the interconnector to make sure we've got stable generation, but we can also export as well. As another backup, we also have diesel engines located in Douglas and also at Peel. So very secure supply. But the key for each of those elements that we've just discussed is the energy, either supplying the gas power station or the diesels or direct imports, is imported from the UK. So 92% of all of our electricity is actually generated from imported energy on the island. We do have a renewable asset, which is Solby Hydro. It's not currently generating anything at the moment to conserve water, but in winter we can generate 1 megawatt from that. And we also generate, as a byproduct of the incinerator, we generate electricity from that as well. So I've kind of touched on the emissions from electricity supply as well. You'll see on the left-hand side a graph showing the emissions from energy supply over the last 20 years. As you can see, there's a major reduction in emissions that comes in about 2001. For those of you who can remember that far back, that's actually when we built the interconnector, and we were building the CCGT for the next 2 years. So our only option was to import electricity, and that represented a substantial reduction in emissions at that point in time. More recently, we've increased the amount of electricity we can import to GB. We can export to GB, and that's actually resulted in an increase in emissions. So it's really important that the place you burn the fossil fuel and release those emissions is where they are accounted. And as mentioned before, electricity is that green sector on the pie chart to the right hand side, representing 1/3 of all our island emissions. So it is the most significant sector at this point in time. We tried to go over the basics with you last time we talked about electricity on the Isle of Man and across the world, actually, in terms of how our electricity is created but also stabilized. So this graph shows the demand across the Isle of Man over 24 hours for one of our most significant periods in demand, which is winter. So this represents the demand for the 21st of December 2019. And you can see there's peaks towards the late afternoon into the evening. Everyone gets home, puts their heating on, starts making tea, puts the telly on. The lights are all on because it's the middle of winter. And that explains the late evening peak. Whereas at night, once we've gone to sleep, we get this dip. And that peak has to be managed very carefully. So our electricity must be stabilised. At the very bottom of the graph, we have what's called baseload generation, and that's provided by baseload plant. there's a summary of the type of baseload plants where we rely on. So fossil fuel generation, coal and gas does provide baseload. Large-scale biomass is a renewable version that provides baseload, a carbon neutral type of generation such as nuclear. Other renewable options, large-scale geothermal and hydro, can provide baseload. Iceland and Norway rely on that, but also the interconnector. And what baseload is doing is giving you a stable supply that makes sure the grid operates within its limits. So all of your appliances are reliant on it being completely stable. At the top section, we have what's called dispatchable generation, and that's plant you can vary. It's highly flexible. If you want it on, it will come on at the very point you need it. So highly flexible. You can also vary the output from it. But the key is it's available when you need it. So at the moment, the only types of dispatchable generation we have are fossil fuel generators. So the gas turbines on island can be dispatchable. And there's also some biofuel options coming down the pipeline, such as biomass, biogas and biodiesel. And the interconnector can also act dispatchably. But of those two elements we've just mentioned, you'll note none of those are either wind or solar, which many of us think about for the future of energy. So I've covered the baseload options available already, but really for the Isle of Man, the things that are suitable scale for baseload is large-scale biomass as a renewable source of energy, small modular reactors, which are the carbon neutral side in development at the moment, and the UK is going down this route very rapidly towards 2050. And the cheapest option for the Isle of Man is an interconnector. So you'll see the prices at the top. For interconnection, we're looking at less than £60 per megawatt hour. Large-scale biomass is the most expensive option at £98 per megawatt hour, and the small reactors are coming in cheaper at £95 per megawatt hour. Each of those has its own benefits and disadvantages associated with those. And all of these have gone into the basic model for what IREP have been working on. Dispatchable options, mentioned those already. Again, interconnector coming in very, very cost effective at less than £60 per megawatt hour. And we also have smaller scale biofuels. So because of the scale of these technologies, they're a lot more expensive than what we saw on the previous slide at £111 per megawatt hour. But the key is if you need them, they are there. And that's a really important aspect for maintaining that security of supply we touched on in the energy trilemma. So intermittent renewables, they do have a part to play in the future of energy. They're sources of generation that are powered by natural resources, wind, tides, solar, but from that aspect, they're also only available when we have those certain conditions. And that can be a problem. So the lack of availability of ability to vary the output from these sources means we really struggle to maintain stable grid while we have these in operation. So without baseload, that isn't really the option for them to be stabilized. And likewise, without dispatchable generation, if we have a day when there isn't any wind, we don't have enough power to meet the demand. Now, a really good example of that is 2 days ago in the UK. The UK now has in excess of 30 gigawatts of wind, so a massive amount of wind. And yet 2 days ago, despite having such an enormous capacity, they were only generating 0.6 gigawatts from that. So a really tiny percentage, 2% of what they had available. And it's just because there wasn't any wind. So I've kind of summarised the technologies for intermittent renewables at the base there, and these costs come from the IREP report. So solar comes in cheap, fairly cheap compared to some of the other options we saw previously at £50 per megawatt hour. So cost-wise, it's great, but unfortunately, it has a very low load factor at 10%. Now, what that means is for 10% of the time, it can meet demand. So today, there is no problem if you have solar panels all of your power can come from solar. But if you think in the midst of winter, when we only get about 2 or 3 hours of daylight with strong sunshine, we really struggle into the evening when people need electricity. Wind slightly more expensive, 52 to 59 pounds per megawatt hour, and a much greater load factor, which is so an average of 37%, and that's between offshore wind and onshore wind as an average. Offshore wind is slightly better, but still only maintains 51% across the year. We have some storage technologies such as hydro. So that is fairly expensive at £99 per megawatt hour. And the key with storage is if you haven't had consistency in the intermittent renewables before you try and store it, that isn't available. Tidal has got a lot of attention over the last, I think, few years really, but at this point in time, it's a very expensive technology, coming in at £286 per megawatt hour, and the load factors on it are typically still really poor. We only generate electricity from tidal at the ebb and the peak of the tide, and in the at the very top of the tide cycles, there's no power being generated at all. But that it is a technology that they are working on, and some point in the future it may be an opportunity to review that technology to use it. So going forwards, now the UK, as I've touched on already, their future is looking at a substantial amount of nuclear generation to provide that base load, and there's also a lot of offshore wind, but they're not doing it in isolation. So there are currently already 4 different interconnectors from the UK to the mainland Europe, and there is an additional 5 interconnectors planned to connect them. And the key with the intermittent renewables is that sharing those intermittent renewables across the continent ultimately provides more reliability. So, for example, Spain has a really high amount of solar energy available to it for most of the year, and the UK is, as we know, a very windy isle. So to share those intermittent renewables around, if you've got excess capacity, is a huge part of the future for the EU to provide security and supply. So where we currently are, now kind of touched on this at the beginning, but demand is expected to rise across the next few years, and that is with the uptake of things like air source heat pumps, ground source heat pumps, and electric vehicles. And that's an issue because we need to make sure we've got enough capacity available to meet that demand expectation. So when you come home, there is always the ability you can put the lights on and that power is there for you. So going forward, the blue line is showing what the demand is predicted, how the demand is predicted to change over the next 30 years. And you'll notice that by 2028, we start to lose the existing plant that we have. It comes to its end of life. So we lose the diesels at Pulrose and Peel, and we require new assets to replace those diesels at this point in time. So that's an investment would be required by 2028, even if we didn't believe there was a climate emergency. Moving forward to 2031, we start to see hydrogen coming down the pipeline from the UK. It's another hot topic, but unfortunately the GTs at the power station have a limit for the amount of hydrogen they can utilise, and so they would need another investment at 2031 to replace them with turbines capable of running on hydrogen. And that's another cost investment. And just with the existing plants and when we are required to change those over is resulting in a significant amount of expenditure over the next 30 years. So we've estimated that cost, including fuel from natural gas, to be £1.3 billion. That is spread across 30 years. It sounds like a huge number, but the issue is if we are starting to see hydrogen in the grid, hydrogen is significantly more expensive as a fuel than natural gas, so that cost could be higher. So that's the other issue. The side to it is the demand change. Future energy scenarios methodology. So we've discussed, we appointed ARUP, they presented to you and discussed some of the technologies they were including at the start of this project. So every single technology that was considered suitable for the Isle of Man and in a position where it was going to become ready and cost effective by 2050 was considered for the modelling. They put all of the technologies into a bucket, if you like, and it ran through a model which delivered what was the most cost-effective solution that still met the trilemma that we discussed and delivered the government's targets. So there was a large team from government helping, providing information that was unique to the island, specifically the grid constraints that we currently have. Understandably, there will be significant cost required to upgrade the network to accommodate changing technologies, and that would be the case regardless of whether we wanted to change how we operate or not. So OVARUP delivered 3 models. Initially, they were presented to us back at the end of April, and afterwards the Climate Change Transformation Board decided that they wanted to see a much greater mix of local intermittent renewables on island. So ARUP removed the requirement for maintaining low cost in their model. And that's given us 5 scenarios. They used a modelling tool called Plexos, which is utilised across the UK by National Grid, across many other countries, as it's a really well respected piece of modelling kit. So first scenario, scenario 1. As you can see, so on the right-hand side of the bar chart, we have the future energy for the first scenario by 2050. So you can see there is a 43 megawatts of solar present in this model, 9 megawatts of storage. So that's representing a large a large solar farm in that model. There's also a small amount of offshore wind turbines at 16 megawatts, but that big blue chunk that's on that graph is biomass. So that biomass, as we've discussed, is required to provide that dispatchable generation. And there's also 140 megawatts of interconnector capacity to provide that base load we discussed as well. And we've got some costs to illustrate what that is likely to be. So we showed you in the previous couple of slides that if we did nothing, it was still going to cost £1.3 billion. In this scenario, we're seeing costs of £1.49 billion, which is spread across the next 30 years. And that's resulting in around £1,142 per household per annum. Significant amount of on-island generation capacity available at 57%. But despite having that capacity, most of the electricity is being imported from GB, and that's because the UK is scaling up so massively in their renewables that the economies of scale means it's always going to be cheaper for us to import, even if we have renewables on the island. Scenario 2 is another import model. So in this case, we have much greater interconnector capacity. So 2 new interconnectors delivering 140 megawatts each. That's to provide a backup to supply. We start to see some very small scale solar in this model at 6 megawatts. So that would be things like solar panels installed on school buildings. So for a large building, that probably is around 12 to 20 buildings that we could cover before we hit that 6 megawatt limit, and it stops becoming cost effective. Biomass is still required in this model to provide that dispatchable generation. And that cost, again, coming in comparable with the very first slide we showed at £1.4 billion, which is representing about £1,000 per household. And as we've got the interconnectors providing most of the power, we've got much lower island generation capacity for that model. Scenario 3 is the most cost effective of all of the models, modelled by ARUP. It does feature some community generation. So there's around 6 megawatts of small scale community solar. This model's got behind the meter generation for new builds, so about 2.3 megawatts of solar on roofs for new build properties, which would be about 50% of all of the new builds that we're expected to complete before 2050. And there's some small community wind projects in this model as well. Now, biomass, again, featuring heavily, providing 71 megawatts of power, a dispatchable generation on the island, with the interconnector still providing the base load. Now, that model is coming in at £820 per household per annum, which, given that is also including some of your household heating and transport bills, it's probably not too far off what you're used to seeing each year at the moment for your bills. So the ability to generate 30% of energy on island, of electricity on island, but we're still importing a very heavy amount for that scenarios. So they were the first three, they were the most cost effective. And like I said, we were asked to go back and see what would be affected if we started to increase the intermittent renewable capacity substantially more on island. So scenario 4, and you'll notice from the scale that this is substantially more renewable capacity than the previous models, actually going up to 377 megawatts, which, given that peak demand is estimated to be 130 megawatts per year, that's a substantial excess capacity. There's 280 megawatts of storage featured in this model, and we would require pumped marine hydro, which is saltwater storage on island. Now, we discussed the trilemma and environmental and the environmental side of that. So while we may see that intermittent renewables is great for to replace fossil fuels to mitigate some of the climate change impacts, that storage of salt water on the island, given our farms and biosphere status, could be significant in terms of the environmental impact. So salt damage to our trees is potentially not great, even though we've got so much renewable capacity. We still require the interconnectors in this model to provide the baseload power, but you'll notice the cost up at 1.8 billion now, and that's because of the initial installation costs of the wind and solar that's present, but also because it's cheaper to import from the UK. And that's representing almost double what we're currently paying for our household bills for electricity at the moment. Massive excess of on-island generation capacity as well at 345%. And there's a note here that cost is excluding constrainment costs. So obviously, with such a high intermittent renewable capacity, and even though we've got storage, once that storage is used up to store energy on a windy and sunny day, we would have to either export electricity at a loss, because the UK would also have a significant amount of renewables on these days, or we would have to ask providers to switch off the supplies, and that would have a cost associated with it as well. Now, scenario 5, even more excess generation capacity in this model. This represents having an 800 megawatt offshore wind farm with all of that power being brought onto the island. So from that, in order to utilise that electricity, we would have to store it. So this model's converting all of that into hydrogen to use at an open cycle hydrogen gas power station. So it can be converted back into electricity. That has an efficiency loss associated with it. So you need a much larger storage capacity to be able to utilise it. It's still got 270 megawatts worth of interconnectors to provide baseload capacity, because it's still not enough using the renewables to not have it. And if, assuming you used all of the hydrogen it's available, we could meet 90% of demand, but there's still 10% that's not met by renewable generation in this model. Now, that cost of this model is fairly huge compared to the other scenarios we've looked at, with estimated cost of 4.5 to 6.1 billion pounds, which, as you can see, is a massive increase to household bills. So this is representing where we would have to get to be totally powered by, or almost totally powered by, intermittent renewables, and you know, the costs show what would happen in that scenario, which doesn't really tie into that trilemma principle we discussed at the beginning. So this is just a summary slide showing the various scenarios and really highlighting how excess that capacity is, given we only need really what's shown in scenario 1 to 3 to give us the resilience and to meet the government targets. So in the short term, there's really only 2 ways we can reduce emissions on the Isle of Man from electricity. A lot of this is due to the implications of the network costs associated with each of these scenarios, and that's going to require a substantial amount of investment and work before we can do anything. So if you look at the UK, where it's at the moment, with nearly 50% renewable capacity, it's been investing over the last 30 years. And we haven't invested at the same level to get where we need to be in order to accommodate renewables on the Isle of Man. So in the short term, we do currently have a green tariff available to business customers. So some are already using this tariff. It allows customers to use energy generated on island from Solby Hydro, but we can also import electricity from the UK. And when I say import electricity, we mean renewable energy from the UK. So the more customers that uptake this tariff, the stronger the likelihood is that it could be rolled out to domestic customers as well. And new businesses, and we're really talking about large scale businesses here, or new business parks, could take themselves off grid completely. They would become 100% carbon neutral in terms of their electricity generation, but it also avoids high consumer costs and it is in line with the just transition. Economic opportunities for the Isle of Man. It's often discussed and often claimed that having a massive intermittent renewable capacity on the island would allow us to export electricity to GB, and it is correct. We can export electricity to GB using the interconnector, but the issue here is that the UK is building so much renewables that they don't need us to provide them with offshore wind and solar. When it's windy here, it's windy in GB. When it's sunny here, it's also sunny in GB. So there's a very limited export potential from offshore renewables at this point in time. CFDs are often discussed with regards to offshore wind, and that isn't currently available to us, but in the future it may be. That would require us to export wind electricity from wind directly to the UK, so it wouldn't come on the Isle of Man. But if we've got an interconnector, we can obviously then benefit from that electricity by re-importing it, and let the UK take all of our stabilisation costs. Dispatchable generators, much better economic opportunities associated with those. So at the moment, the UK is short of dispatchable generation, and that is what we are using in order to sell electricity to the UK at the moment from the CCGT. The scenarios from ARUP all show that generating electricity from biomass allows us to decrease the cost of electricity on the Isle of Man. So at times when the UK has very high peak charges for electricity, which are always because there isn't enough wind or solar at that point in time, because the resources aren't available, those points would enable us to reduce the cost of electricity by using biomass, and that's been shown across all the models that it's the best way to maintain low cost of generation on island. If we were to scale that up, there is a potential to export electricity back to GB at those times when it's short, but it would require us to import biomass from GB because there isn't enough material on island to generate to operate sustainably. And the last section we've got there is baseload generators. So UK is also short of baseload, and it's predicted to become short of baseload over the next decade. You might have seen several of the UK nuclear power stations are due to retire very quickly, and the existing generation, or the first generation, will all come to their end of life in 2030s. And that becomes a problem if the UK isn't able to build enough of these stations quickly over the next 10 years, and they are struggling to find sites. I don't know if anyone saw the issues in the Republic of Ireland in May, but after decommissioning their coal stations and replacing them with wind, they fell short of baseload power, and across those times, they actually had major blackouts, I think 3 days in a row, and that shows the issues of losing this stabilising power. So there could be an opportunity for the Isle of Man to build a baseload station, allowing us to export to either the Republic of Ireland or GB. Both these markets are short of electricity. But that hasn't been considered in the model. It is not regarded as the most cost-effective solution for the island. So next steps, you may have seen we're planning to consult on these scenarios over the summer as part of our 5-year climate change plan. There will likely be a decision on the preferred pathway after the elections, and it's clear at this point what we need to get across is that these scenarios represent possible futures, but we will constantly need to re-examine these across the next 30 years. Technologies will evolve, they will become cheaper, there will be some technologies that we haven't thought of at this point in time that become cost effective down the pathway. We know, regardless of what path we take, we will need an interconnector. That is a no-regret decision at this point in time, and Manx Utilities have already started with a feasibility study to support this work, and we will need to build this new cable in the next 10 years to make sure we can maintain security of supply. There's some additional work that needs to be done. So we are currently working on our renewable heating strategy and our transportation strategy, which will show exactly how much demand we need to meet from things like EVs and electrified heating. We need to identify a source of sustainable biofuel. So we know we have 30,000 tonnes of biofuel to be used from our plantations. It's already been set aside for use in heating that we can use, but we want to make sure it can be sustainable, because that is what makes biomass renewable. There are other opportunities involved in biofuels as well. Things like miscanthus can be grown by farmers, and that can be done sustainably as well. So there's significant opportunities in that fuel. And I think that's really all we've got to discuss. So in summary, the work has shown that there are feasible pathways to achieve net zero in electricity by 2050, and that they're also cost effective, affordable, and can keep our level of resilience that we've got at the moment. The second point, the cost of generating on island from renewables is more expensive than importing power. We saw that from all of our scenarios. The most expensive scenarios are ones that include a high level of intermittent renewables. And the last point is the timescales that's involved in these projects. They are significant large infrastructure projects that will take 5 to 10 years. We're not going to be seeing an immediate reduction by constructing new assets unless we start to import power down the interconnector. And that is one of the questions that is coming out in the consultation. I think that's it for now. Thank you for listening.
Aida, you've put your hand up. Do you want to type your questions?
There's a lot to take in, guys, isn't it? A lot of information. I don't know if I'm like you. I was like, oh, it's a lot of information. You can always come back to us with any questions at a later date. Don't feel you have to under pressure to ask any now.
Aida's put her hand up, but she's not. Oh, I've got a question from David. You mentioned an interconnector to GB, but can we connect to RI to give us more security?
Yep, so that's a really good point from David. And if you look at some of the concerns that happened with Jersey in the last couple of months, they have 3 interconnectors that connect them to France, but those interconnectors all go to the same place. And a couple of years ago, there was a trawler that took up those interconnectors because they're on the same place. So it's not secure to have interconnectors going to the same country, and it's not secure to have them all in the same place. So an interconnector to the Republic of Ireland could be a very good idea, and that would give us more control over the cost of our electricity. So we could import from Ireland, for example, or export to Ireland if the costs made that viable.
Great. I think that answered the question. We've got a couple more questions. So the next one's from Sharon. In scenario 2, you said small scale solar is not suitable to go higher. Can you explain why?
Just specifically in scenario 2? So that's the most cost-effective solution that we've shown in across these scenarios. So you can, of course, put more solar power on the island, but the costs will be high. And a lot of that comes from the issues we have with balancing that power and stability. So we will, regardless, have to build an interconnector to provide us that stability. Ideally, we would have dispatchable generation to offset the high costs. But if we're importing from the UK, when it's cheap to import from the UK, they will have a massive solar capacity. So if they're building, for example, 200 megawatt solar farms, the economies of scale means it's always going to be cheaper to import from those than to generate our own electricity. And it's detailed in the full RUP report, but we do have an uplift on the island. So construction projects are more expensive on the island just because of getting supplies across to us and the work compared to building in the UK. Hope that answers the question.
Great, thank you. So got more coming in. The next one's from Aida. What is the surface required to produce biomass for 71 megawatts?
Right, okay, so in each of those scenarios we saw, the first 3 scenarios that include biomass, they are all using 30,000 tonnes of biomass per year, and the existing plantations can already accommodate that power. So if we want to upscale that, we would have to import, and there is a land management strategy that's going to be rolled out this summer to look at other ways we could do that and how we might be able to increase this. The problem is we don't want to increase it too much on Ireland because we don't want to lose our biodiversity that we have available. That would lose the aspect of the environment in the trilemma. So the key is a little can help us, but we don't want to be doing massive amounts.
Thank you. Another question from Aida. Have you got a scenario where one interconnector provide base load, the other provide spot peak electricity coupled to wind offshore, which has 50% load factor? Do you want me to repeat that?
So I think that question was, do we have just one scenario that's got one interconnector? And we don't do that. The reason for not doing that is because if you only have one interconnector, when they go to maintain and that interconnector and carry out an outage, that means that you wouldn't have any power on the island, even if you had wind, because there's nothing to stabilize it. So it's really important that you have that stabilization, otherwise you don't have power.
Okay. The next question, back to biomass. If we're using biomass, are we looking to use carbon capture? And if so, was that included in the costs?
Right, so I think if you look at the UK, they are using biomass to go carbon negative. So the UK's got substantial challenges in other sectors. For example, agriculture is a very challenging sector to go carbon neutral with. So if you make sure your electricity is carbon negative, it takes some of that burden off. So in our scenarios, we haven't looked at carbon capture, but that's because we're removing the CO2 before the biomass is burnt in the generator. And as long as that's done sustainably, you're always removing more carbon from the atmosphere as the trees grow than you're producing at the other end. But we could add carbon capture to it as well if we wanted to go negative. There just isn't cause to do it on the Isle of Man at this point in time.
Okay, thank you. The next is just trying to understand what is 30,000 tons. How much electricity does it use? Just to understand what, to understand how much.
So I think Aid is asking. Then there's full detail of this in the RIP report about how that electricity is used. But for example, the 131 megawatt biomass plant that was shown in scenario 1 cannot possibly run 100% of the time to at 131 megawatts. And only use 30,000 tons of biomass. So scenario 1 biomass is used a lot less than scenario 2, and even less, even if it's used even less than the one in scenario 3. Scenario 1's biomass is also acting as a peak backup station. So if the interconnector is unavailable, you can run on biomass for 2 weeks using 30,000 tons at 131 megawatts. But ideally, you wouldn't want to.
Okay, I'll move on to the next one. Is there a scenario which includes electricity generated from individualized domestic solar power generation?
Yep, so scenario 4 that we looked at actually has 50% of all buildings on the island covered in solar. And again, the issues, economies of scale, if you're only using small installations, there isn't going to be the cost of doing loads of small installations is much greater than the cost of building one very large installation, and that starts to show where some of it is becoming ineffective. Scenario 3 does also have some rooftop solar installed. It's not on a massive scale, but it is enough that you could, for example, using the just transition principle, apply it to social housing to make sure that the people who are not as well off are not burdened by high electricity bills.
Okay. Next question is, what is the alternative to bio oil and how it is produced? I think it's, yeah, what's the alternative to biofuel and how is it produced?
I'm not sure I understand the question. There's many types of biofuel. So there's solid biomass, which would be the plantations. And you would need some sort of pellet mill to be able to produce power from that. There's other types of biofuel, things like bio oil, which is grown from vegetable crops. Can you still hear me?
Yes.
Okay. So rapeseed oil, for example, can be converted so you can power generators off it. In fact, the gas turbines at Pulrose can potentially be adapted to run on biofuel because they can already run on diesel. There's other types of biofuel would be biogas, for example, which can be produced from sewage or animal waste as a byproduct. But looking at the research we have available, it doesn't look like there's a massive opportunity for that on island unless we started to use seaweed for anaerobic digestion. But other than biofuels, in terms of dispatchable generation, there really isn't many. There aren't any other options that are in line with the just transition principle. With the climate change targets. Because the other options on dispatchable generation would be diesel or gas turbines.
Okay. Just reading the questions now. This is coming in quick and fast. Okay, so the, the next question is, if you have 30,000 tons of biomass available and you are constraining your power output due to local availability, is it viable to import the balance from the UK?
So is that importing, I assume it's importing biomass from the UK. We could do that, and we could ensure we put in our supply chain to make sure, or put in a constraint in the supply chain to make sure we have sustainably sourced biomass from wherever it's coming from. But the UK in particular has run into big issues with the sustainability of its own biomass. So Drax, highly topical, a lot of that energy source is not sustainable. It's not been sustainably sourced and has damaged ecosystems. So we want to avoid that. We will need to look further into how much can be imported, but obviously the interconnector is providing that balance. And again, not clear from this presentation, but as we start to move past 2040, the cost of electricity in the UK is estimated to come down significantly, at which point it would be very unlikely that we would need to use dispatchable biomass as much in any of the scenarios.
Okay. Just going through the questions. Missed anything?
I put in a couple of chats, but you haven't. Have you seen them?
Let me just have a look. Right, Lizzie,
questions, John. It's are we getting a lot of questions, Rose?
Yes. So,
Yeah.
so this one about have we considered disposal of solar panels once after it's been used? In the scenarios.
So that hasn't been done in the scenarios themselves. Obviously, when we went, if we were to go down a particular route, we would be asking any supplier to complete an environmental impact assessment, and it would include the end of life use of these solar panels. The EU has started a lot of initiatives, and they're requesting some of the suppliers to make sure they can recycle certain technologies. But you've just highlighted the point there, the trilemma as well. We're not just talking about CO2. There are other environmental issues for each technology, and we do have to be aware of those.
Great, thanks.
Someone blowing the nose.
Any of those? Let me just see if I missed one. I think this is one that you mentioned, John. He just mentions that biomass is controversial because of the CO2 emissions, and generation of hydrogen is expensive. And he just points out that we should concentrate on well-tried solutions such as the CCGT and nuclear. Also points out that the electricity costs in the UK will rise as greater subsidies from wind farms are factored in.
Right, okay, so correction on some of those things. The CCGT, we do have a problem with maintaining the CCGT, and that's acknowledged by Manx Utilities. It is coming to its end of life, regardless of whether we cared about climate change or not. We would have to pay money, a significant amount of money, to replace that plant to keep it going past 2031, which is its end of life anyway. And that's actually when RFR modelling that it needs to come off anyway. So I touched on hydrogen. We don't have a choice if hydrogen comes down the pipeline. It is expensive. We're acknowledging it's expensive, but if it does come down the pipeline, that's what we're going to be paying for, because we can't produce our own. We're not producing our own natural gas. It is imported. So that is a challenge, and that would have been a challenge regardless. And actually, the costs that we're seeing that have been modelled are showing that that isn't the most cost-effective route, even if we wanted to keep using the CCGT and we didn't have government targets to meet. It does need to come to its end of life regardless. There are issues with biomass, and that's a point. If we were going to import biofuel, it does become a problem, because we need to make sure it is sustainably sourced. The sustainability of biomass is key to making sure the CO2 emissions aren't there isn't controversy with it. It's a tried and well measured approach that we're taking, and that's why the land management strategy is going to be completed following this work to make sure it is done right.
Great, thank you. There's one question. I'm not quite sure if it's something that we can answer, but I'll ask and you can let me know. It's from David. He said, we mentioned biogas, and given that we're looking to build several new sewage treatment plants around the island, are there any of these looking to be anaerobic digesters, which would allow us to use the gas produced?
So I've asked this question specifically already to the sewage team at Manx Utilities. Now, they did look into anaerobic digestion as a possible way of dealing with it. And I don't know if everyone's aware, but actually at the moment, the sewage treatment works produces dry matter that ends up going to the energy from waste plants. So we are already using biomass on the island from sewage waste. And it's more cost effective and more energy efficient to do it that way. There simply isn't enough biogas available. I did touch on what we would probably need to do for biogas if we were going to do it on a greater scale is utilise the seaweed, that the waste seaweed that ends up washed on the beach. That there's a much greater source, and that will be looked into as a feasibility study after the consultation if the public do support the use of biofuels. But we don't have information on that at this point in time. If anyone's interested more in the biomass and biogas side, there was a report done by AEA back in 2009, and it also concluded that biomass was the best way of generating of using energy on island, either from heat or from electricity. And they did mention seaweed and anaerobic digestion in that report as well.
Great, thank you. No more questions, I think. Yeah, that's everything.
I hope that's okay. If anyone's got any more questions, I'm more than happy to deal with them. Oh, I see there's another question.
Yes, there is. What is going to happen with pipe gas to houses and businesses? There is no viable hydrogen production in the UK.
I don't understand the question about viable hydrogen production. We are already generating hydrogen in the UK, and they have hydrogen going into their grid. The Western Hebrides have hydrogen gas grids, not 100%, but lower thresholds. And there's also a test installation down in Cornwall, and a lot of sorry, there's loads of questions popping up. Sizewell C, which is a new EPR facility that is due to be commissioned in the next 10 years, is going to be built alongside carbon capture and a blue hydrogen facility. The issue with the gas grid is not that we can't generate hydrogen. We know we can generate hydrogen from renewables. The issues with it tend to be more the storage of hydrogen, and that's where the cost comes from with either blue hydrogen or green hydrogen. Sorry, Mike. The other side, I think you've touched on the gas heating customers at the moment. So we are in the middle of completing a renewable heating strategy with another set of partners called GemServe, and I know several of you have already helped us out with that study, and we'll be feeding back on that study in the first week of September for anyone who's interested. So we're aware of the issues with hydrogen, and for that reason, we've tried to look at how we can manage existing gas customers to make sure they're not adversely affected by this. And it should be mentioned, the gas grid itself can accommodate hydrogen, and existing fossil fuel boilers can run on hydrogen. It's the gas turbines at Pulrose that are the issue. Other gas turbines could run on hydrogen. We would need to replace them. So there are options. It's just not the ones we've got.
Okay. Anything from blue or green hydrogen? Let me see. I think it's just following on from what you say. There will not be significant blue or green hydrogen in the UK. All H2 is grey. The grid experiment is in Kiel as a pilot.
So REP actually did the UK's gas grid study for hydrogen, and that's commented on in the report, but they are expecting there to be significant amounts of hydrogen in the gas grid by 2030. So I don't think it's correct to say it's definitely not going to happen. I think it's a really key area that the UK is looking into at the moment, but it is uncertain. It may not end up having a lot of blue hydrogen in the gas grid, but the research is showing that REP is doing, and certainly a lot of the comments that are coming out from UK government at the moment is suggesting that they do intend to have significant amounts of blue hydrogen. That said, we're not talking about importing hydrogen for our models at all. In fact, I don't think that's been shown in any of them.
Okay.
How are we doing on questions, Rose? Are we?
Yeah, so I've got two questions, and they're similar. They're related. They're about seaweed. I think because you mentioned about seaweed, and it's just an important part of ecosystem, and is that taken account? And someone asked if there's a link to a seaweed study that you can direct them to, so something for them to read, possibly after this.
We can send the link out to the AEA study after this meeting. It was only touched on in passing in that study. We would need to do more research, but I can't remember the other question. The ecosystem side of it. So we are only talking about the seaweed that ends up on the beaches. We're not talking about digging up seagrass to use for anaerobic digestion. Seagrass is really important for environment, and my colleagues will be discussing the benefits of that and blue carbon over the next few sessions. I think next Monday probably as well. So this is definitely just waste seaweed we're talking about.
Okay, brilliant. All right, guys, it's a lovely evening out there. We'll come to and we'll wrap things up now. Then I want to thank Lizzie so much for presenting to us tonight, and thank you all for coming. I know it's been, it's so hot still, so thank you for joining us. We really appreciate it. We will be in touch about Monday's Citizens Forum. I'll be in touch with you tomorrow, so keep an eye out on your emails. We are monitoring the situation at the moment. So that's why I sort of asked you at the beginning, if we did move it online, what you all think. But yes, it's we'll say goodbye, and thank you so much again for joining us. Thank you, Lizzie. Thank you, Rose. And we'll hopefully either see you online Monday or in person. But look out for my email. I will be in touch tomorrow.
Thank you, everyone.
Thank you. Bye.
Yeah, thank you.
Thank you. Bye, everybody.